Panelboards are generally not permitted to be installed in stairwells and corridors that serve as paths of egress. This restriction is in place due to safety concerns and is addressed by both the National Electrical Code and the NFPA 101 Life Safety Code. According to the National Electrical Code, panelboards should not be located in stairwells or corridors designated as paths of egress. The NFPA 101 Life Safety Code also prohibits the installation of electrical equipment, including panelboards, within exit enclosures. There are several reasons for this prohibition. Firstly, panelboards can obstruct the path of egress, particularly in narrow stairwells and corridors, hindering the safe and efficient evacuation of occupants during an emergency. Secondly, electrical equipment, including panelboards, can generate smoke and heat during a fire. This smoke and heat can further impede evacuation efforts by reducing visibility and creating hazardous conditions. Thirdly, panelboards located in stairwells and corridors may be difficult to access for inspection and maintenance purposes. This can lead to delays in identifying and addressing potential electrical hazards. However, there are some exceptions to this general rule. One exception applies to buildings that are protected by automatic sprinkler systems. In sprinklered buildings, panelboards may be permitted in stairwells and corridors if they meet specific requirements for fire resistance and accessibility. These requirements are designed to minimize the risk of fire spread and ensure that the panelboards can be safely accessed for maintenance and repair, even during a fire. Another exception may apply to renovated or historic buildings. In historic buildings that cannot be modified without significantly altering their architectural character, existing panelboards in stairwells and corridors may be allowed to remain if they meet certain safety criteria. These criteria are designed to ensure that the panelboards do not pose an undue risk to the safety of occupants. It is important to note that the specific requirements for panelboard installations in stairwells and corridors can vary depending on the applicable codes and regulations in a particular jurisdiction. Therefore, it is always recommended to consult with a qualified electrician or code official to determine the specific requirements for a given project. When evaluating existing installations, several factors should be considered. The width of the stairwell or corridor is a critical factor. If the panelboard significantly reduces the available width, it may be considered an obstruction to egress. The presence of fire protection systems, such as sprinklers, can mitigate some of the risks associated with panelboard installations in egress paths. The overall condition of the panelboard and its electrical connection should be assessed to identify any potential hazards. The accessibility of the panelboard for maintenance and inspection is also important. If access is limited, it may be difficult to identify and address potential problems. If a panelboard is found to be in violation of applicable codes, corrective actions may be necessary. These actions could include relocating the panelboard to a more suitable location, installing fire-rated enclosures around the panelboard, or upgrading the electrical system to meet current safety standards. In summary, panelboards should generally not be installed in stairwells and corridors that serve as paths of egress. This is a safety concern and is addressed by both the National Electrical Code and the NFPA 101 Life Safety Code. Exceptions may be allowed in certain circumstances, such as sprinklered buildings or historic buildings, but these exceptions are subject to specific requirements. If you come across a panelboard in a stairwell or corridor, it is recommended to consult with a qualified electrician to assess the situation and determine if any code violations exist. A panelboard is an essential component of an electrical distribution system, serving as a central point for dividing electrical power feeds into subsidiary circuits. These circuits provide power to various loads throughout a building. Understanding the construction and function of a panelboard is crucial for electrical safety and proper system operation. Panelboards typically consist of a metal enclosure containing busbars, overcurrent protection devices such as circuit breakers or fuses, and connection points for wiring. The busbars are conductive bars that distribute electrical power from the main incoming feed to the branch circuits. Overcurrent protection devices are designed to protect the circuits from excessive current flow, which could cause overheating or fire. The National Electrical Code, or NEC, provides comprehensive guidelines for the installation, wiring, and protection of electrical systems, including panelboards. Adherence to the NEC is essential for ensuring electrical safety and compliance with local regulations. Article 408 of the NEC covers the requirements for panelboards, including their location, installation, and overcurrent protection. Proper grounding and bonding of panelboards are critical for preventing electrical shock hazards. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Regular inspection and maintenance of panelboards are essential for ensuring their continued safe and reliable operation. Inspections should include checking for loose connections, damaged components, and signs of overheating. Maintenance tasks may include tightening connections, replacing worn or damaged components, and cleaning the interior of the panelboard. When working on or near panelboards, it is essential to follow safe work practices. These practices include de-energizing the panelboard before working on it, using appropriate personal protective equipment such as insulated gloves and eye protection, and following lockout-tagout procedures to prevent accidental energization. Understanding the principles of overcurrent protection is essential for selecting and installing the correct overcurrent protection devices for a panelboard. Overcurrent protection devices are designed to trip or blow when the current flow exceeds a predetermined level, protecting the circuit and equipment from damage. Circuit breakers are commonly used as overcurrent protection devices in panelboards. Circuit breakers are designed to trip automatically when an overcurrent condition occurs, interrupting the flow of electricity. Fuses are another type of overcurrent protection device that can be used in panelboards. Fuses contain a fusible link that melts and breaks the circuit when an overcurrent condition occurs. The interrupting rating of an overcurrent protection device is the maximum amount of current that the device can safely interrupt without failing. It is important to select overcurrent protection devices with an interrupting rating that is sufficient for the available fault current at the panelboard location. The available fault current is the amount of current that would flow in a short circuit condition. It is important to calculate the available fault current to ensure that the overcurrent protection devices are properly sized. The selection of conductors for use in panelboards is also important. Conductors must be sized appropriately for the amount of current they will carry, and they must be properly insulated to prevent electrical shock hazards. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. Proper labeling of panelboards and circuits is essential for safety and convenience. Labels should clearly identify the purpose of each circuit and the location of the corresponding loads. The NEC requires that panelboards be labeled with the name of the manufacturer, the voltage rating, and the ampere rating of the main overcurrent protection device. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates a high temperature arc. Arc flash can cause severe burns, blindness, and even death. It is important to take precautions to prevent arc flash hazards when working on or near panelboards. These precautions may include wearing arc-rated clothing and using insulated tools. An arc flash hazard analysis is a study that is conducted to determine the potential arc flash hazards at a particular location. The results of an arc flash hazard analysis can be used to develop safety procedures and select appropriate personal protective equipment. Coordination studies are conducted to ensure that overcurrent protection devices are properly coordinated to minimize the extent of an outage in the event of a fault. Coordination studies involve analyzing the time current characteristics of the overcurrent protection devices to ensure that the device closest to the fault will trip first. Selective coordination is a type of coordination in which the overcurrent protection devices are coordinated to ensure that only the device closest to the fault will trip, minimizing the impact on the rest of the electrical system. Surge protection devices can be used to protect panelboards and connected equipment from voltage surges caused by lightning strikes or other electrical disturbances. Surge protection devices divert the surge current to ground, preventing it from damaging sensitive electronic equipment. Harmonics are distortions of the sinusoidal waveform of alternating current. Harmonics can be caused by nonlinear loads such as electronic equipment and can cause problems such as overheating of equipment and reduced power quality. Harmonic filters can be used to reduce the level of harmonics in an electrical system. Power quality is a measure of the quality of the electrical power supply. Poor power quality can cause problems such as equipment malfunction, reduced efficiency, and increased energy costs. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Energy efficiency is the measure of how efficiently electrical energy is used. Improving energy efficiency can reduce energy costs and reduce the environmental impact of electricity generation. Energy-efficient lighting, motors, and other equipment can be used to reduce energy consumption. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction capacitors can be used to improve power factor. Demand response is a program that allows electricity consumers to reduce their electricity consumption during peak demand periods in exchange for financial incentives. Demand response programs can help to reduce the strain on the electrical grid and prevent blackouts. Distributed generation is the generation of electricity at or near the point of consumption. Distributed generation technologies include solar photovoltaic systems, wind turbines, and fuel cells. Distributed generation can help to improve the reliability and resilience of the electrical grid. Microgrids are localized electrical grids that can operate independently from the main electrical grid. Microgrids can provide a reliable and resilient power supply for critical facilities such as hospitals and data centers. Smart grids are electrical grids that use advanced technologies to improve efficiency, reliability, and security. Smart grid technologies include smart meters, advanced sensors, and communication networks. Electrical safety is paramount when working with panelboards. Never work on a panelboard while it is energized unless you are a qualified electrician using proper personal protective equipment and following established safety procedures. Always verify that the panelboard is energized before beginning any work. Use a properly rated voltage tester to confirm the absence of voltage. Lockout-tagout procedures are essential to prevent accidental re-energization of the panelboard while work is in progress. Clearly identify all circuits and components within the panelboard. Use appropriate labeling to avoid confusion and ensure safe operation. Regularly inspect panelboards for signs of damage, overheating, or loose connections. Address any issues promptly to prevent potential hazards. Keep the area around panelboards clear of obstructions to ensure easy access for maintenance and emergency situations. Be aware of potential arc flash hazards and take appropriate precautions to minimize the risk of injury. Follow all applicable electrical codes and regulations. Consult with a qualified electrician if you have any questions or concerns about panelboard safety. The size of a panelboard is determined by the load it will serve and the available space for installation. Panelboards come in various sizes, ranging from small residential panels to large industrial panels. The size of the panelboard is typically expressed in terms of its ampere rating, which indicates the maximum amount of current that the panelboard can safely handle. The number of circuits in a panelboard is also an important consideration. A panelboard should have enough circuits to accommodate all of the loads that it will serve, with some spare circuits for future expansion. The type of overcurrent protection devices used in a panelboard is another important consideration. Circuit breakers are the most common type of overcurrent protection device used in panelboards, but fuses may also be used in some applications. The interrupting rating of the overcurrent protection devices must be sufficient to handle the available fault current at the panelboard location. The wiring within a panelboard must be properly installed and secured. All connections must be tight and free of corrosion. The conductors must be sized appropriately for the amount of current they will carry, and they must be properly insulated to prevent electrical shock hazards. The panelboard enclosure must be properly grounded to provide a safe path for fault current to flow to ground. The grounding electrode conductor must be properly sized and connected to a grounding electrode system. The panelboard must be properly labeled with the name of the manufacturer, the voltage rating, and the ampere rating of the main overcurrent protection device. The circuits within the panelboard must also be labeled to indicate the purpose of each circuit. Panelboards should be installed in a location that is readily accessible for maintenance and inspection. The area around the panelboard should be kept clear of obstructions. Panelboards should be protected from physical damage. They should not be installed in areas where they could be exposed to moisture, dust, or corrosive substances. Panelboards should be inspected regularly to ensure that they are in good working condition. Inspections should include checking for loose connections, damaged components, and signs of overheating. Any problems that are found should be corrected promptly. Panelboards should be maintained in accordance with the manufacturer's instructions. Maintenance may include tightening connections, replacing one or damaged components, and cleaning the interior of the panelboard. Only qualified electricians should perform work on panelboards. Working on electrical equipment can be dangerous, and it is important to have the necessary training and experience to do the work safely. Always de-energize the panelboard before working on it. Use a properly rated voltage tester to confirm the absence of voltage. Follow lockout-tagout procedures to prevent accidental re-energization of the panelboard while work is in progress. Use appropriate personal protective equipment, such as insulated gloves and eye protection, when working on panelboards. Be aware of potential arc flash hazards and take appropriate precautions to minimize the risk of injury.